once again. Welcome to One Mark Solutions. Please subscribe, like, and share to your friends. Now, third case under the heading Electrostatics. Electrostatics, we can say two chapters are there. First chapter is electric charges and fields, and the second chapter is electrostatic potential and capacitance. So together it will come under one unit. Now we are dealing with the case 3. And you know that case study is very important. 2 case studies there. And out of that, we can say that 8 marks will be there. In one case study, 5 questions will be there. Out of that, only you have to do 4. And another one case, we can say 4. So let us start with this case study. That means charging by induction. Now we are going for charging by induction. That is our topic, we can say. Now you can say that figure shows an uncharged metal. You can just see a figure here. You can see a metallic sphere here, right? And here we can say that a rod which is negatively charged, which is placed very near to the sphere. So what is happening here? It is not connected. It is not in contact. It is placed very near to it only. So what is happening here? The charges, the opposite charges will be placed very near to it. That means all the positive charges will accumulate here and the negative charges will be the other side. If you are connecting, you can see in the second figure B. The figure B, you can see that the positive charges here and the negative charges there. That means these negative charges will attract the positive charges here and the farther end the negative charges will be there. So what is happening in the C? We are connecting to A. What is it? We are connecting with the wire to the earth. We will call it as grounding or earthing, we can say. So what will happen? All the negative charges will go to the ground. So only the positive charges will be remaining. Here the road is here. As far as the road is here, the positive charges will be accumulated there itself. If you're removing the road, what will happen? The positive charges will be, we can say equally distributed. Now what we are getting, the positively charged metallic sphere, positively charged metallic sphere. In the first case, we can say, the first figure, you can say that no charges are there. This process, we can call it as charging by induction without any direct contact. And one more thing we can say, if you are counting the charges, how many charges in this negatively road, we can say 1, 2, 3, 4, 5, 6, 7, 8, isn't it? So after the charging by induction also, you can see 8 charges are there. So we are not losing any charges. So without any loss of charge and without any direct contact, this process will take place. And this process we can call it as charging by induction. Once again, I'm telling, the process of inducing opposite charges. If you want to get positive, you have to place negative. If you want to get negative, we can place the, positive charge. That is the only difference. The process of inducing opposite charges without any direct contact and without any loss of charge, we can call it as charging by induction. Now I'll just read it out. If we bring a negatively charged rod close to the metallic sphere, as the rod is brought close to the sphere, the free electrons in the sphere move away due to repulsion and start piling up. That means it will accumulate at the farther end. The near end becomes positively charged due to the deficit of the electrons. This process of charge distribution stops when the net force on the free electrons inside the metal is 0. If the force on the free electrons inside the metal is 0, we can just stop it. Now, if we connect the sphere to the ground by a conducting wire, what will happen? That means grounding or earthing, all the charges will move to the ground. That we have explained it once again. The electrons will float to the ground while the positive charges at the near end will remain held there due to the attractive force of the negative charges on the rod. That is as shown in the figure. You can see the last figure. That means D. The figure D, you can see that positive charge is still there because of the force of attraction by the negatively rod. Now, disconnect the sphere from the ground. The positive charge continues to be held at the near end. If we remove the electrified road, what is happening? We can say the positive charge will spread uniformly over the sphere as shown in figure. In this experiment, the metallic sphere gets charged by the process of induction, and the road does not lose any of its charges. That is why I told that the process of inducing charge without any direct contact and without any loss of charge, we can call that process as charging by induction, or we can call it as electrostatic induction. That is one of the very important topic in this electrostatics. The first, we will go for the questions. First question, based upon this charging by induction, we can go for the questions. The first one, what do you call the process of charging a conductor by bringing it near another charged object? Without any hesitation, you can say the answer, induction, no doubt. Here it is given polarization, neutralization, conduction. All these things you know that, and you are familiar with the polarization in the optics, neutralization, of course, you know, and the conduction also, you know. So the answer is no doubt, without any doubt, the first answer, that is induction only. Now we can go for the second question. The negatively charged balloon is brought near the two cans. What happens? See that here charging by induction also takes place. The negatively charged balloon is very near to the can A. So it will be inducing the opposite charges. So what will happen? The negative charges in can B move towards the balloon, or can A move away from the balloon, or can B move towards the balloon? What will happen? We can see that the answer is the negative charges in the can A. That means in the can A, the negative charges, I told you, know, what is it? Negative will be attracted by the positive, and the other end, the farther end negative will be there. Sure, the negative charges will be moving away from the balloon. So that is the correct answer, B. The negative charges in the can A move away from the balloon. And you can see that you can just go through the first one, second one, third one, fourth one. If you're going, you will get the correct answer, that is answer B only. Okay, now we can go for the next one. The transferring a charge without touching is. Transferring a charge without touching is. What will be the answer? No doubt, that is induction. Without any contact, without any loss, and inducing opposite charges, we can call it as induction. Now we can go for the fourth question. Due to electrostatic induction in aluminum rod, due to charged plastic rod, the total charge on the aluminum rod. Just think it about. The process is electrostatic induction. That is in aluminum rod due to the charged plastic rod. Plastic rod is charged, but the total charge on the aluminum rod, no doubt, it is equal to 0. And now we can go for the fifth question. If we bring the charged plastic rod near neutral aluminum rod, then rods will repel or attract or remain their position, exchange charges. You can think it once again. The plastic rod near the neutral aluminum rod. And we know that when it comes, what is happening? They will attract each other. So the answer will be B, that is attract each other. Now, thank you for watching 1 Mark Solution. Please subscribe, like, and share. Thank you once again.